Good morning, everyone. Thank you for listening in. My name is Maribel Tomás Rocha, and I'm an ATM consultant at Think. I'm also the project manager for RoMiAD, which today I will be introducing you to. Project RoMiAD is sponsored by the Engage KTN, and it studies how to use market mechanisms in order to incentivize the transition towards the deployment of the Airspace architecture study. This project is ongoing, and in this presentation, I aim to show you what we have been working on, the direction of the project, and the assumptions we are starting to testing with some stakeholders. This will include talking about the big virtualization picture, what benefits does it bring, and how can we incentivize those benefits. Currently, ATM is a monolithic architecture at national level. This brings limited interoperability between the systems, which are high on costs and have low efficiency. The Airspace architecture study, launched a couple of years ago, provides a technical and organizational blueprint to change this. The idea is to have the current vertical systems, break them down, and then reintegrate them into a horizontal system in order to make better use of economies of scale. In order to incentivize the transition, we need to make the changes at an organizational level. Currently, air traffic control decisions on a flight are made in a discrete manner by every single controller, and this leads to a more or less okay solution. This idea supports first come, first serve. However, if we manage to make continuous decisions throughout all the flight will transverse smoothly through all the stages of air traffic control. And this supports real gate-to-gate trajectory-based operations. It enables to make collaborative decisions to have better flights and network optimization. However, this is impossible today. It just cannot happen. It does require a common data layer that enables data sharing to make the right decisions throughout the whole flight to have the perfect flight. And this is not only about optimization, about operational optimization. It's about creating a better arch to deploy automation. Because once every operation is harmonized throughout Europe or through our regional systems, then it's much easier to take the next steps. The way we are going to go forward with this study is to understand the transition layer by layer. We need to understand the size, the benefit, and how to best optimize the reorganization and performance efficiency in each individual layer. The transition we are looking at is made of 3 layers. First of all, the ATS layer, which supports the virtual center concept where multiple ACCs work together in order to control flights. Then the common data layer, which provides the ATM data services and integration services in a cloud environment which any stakeholder, and in particular the ACCs, can subscribe to. This is fed by the physical layer, which is the rationalization of the current auxiliary services, so CNS, AAS, MET. In the ATS layer, the idea is to group multiple ACCs to share airspace across Europe and operate seamlessly as a single center. This requires procedures and systems to be the same across all the centers in the group. So, handovers between controllers need to be identical within a center and between the different centers. The controller working positions need to be configurable to any sector, and therefore the validation of the controllers has to happen on the system and not on the sector. But what virtual centers are not is a consolidation of the ACCs. So states do not need to give up the sovereignty, they just need to collaborate. And if we manage to harmonize, to make use of trajectory-based operations instead of first come, first served, then we will have a system that operates efficiently, that enables automation, and that can achieve all these ACCs to be best in class, as proposed in the Operational Excellence Program of Eurocontrol. The idea is also that if you have a wider scale of operations, you can optimize airspace according to the traffic flows. In this layer, continuity occurs at the virtual center layer. So individual centers do not require individual sites. They can use their other centers in the groups to have the contingency, because capacity can be moved wherever is required. The network can operate collaboratively to be flexible and to have a scalable system. Because right now, if we go back to 2018, when delays were really high, it was not a problem of capacity. The capacity was there, it was just in the wrong places. And as we can see in the map, the sectors towards the center of Europe are very small, and this is where the busiest airspace is. However, to add more capacity here, we cannot redesign the airspace, or at least it's quite difficult. What is required to lower delay is collaboration. And we can do it by introducing the concept of capacity on demand, which is the ability to move spare capacity where is needed. In the common data layer, the idea is, rather than having data within each single ACC or ANSP, we could move the data and the integration services into the cloud, where all the stakeholders can subscribe to it. To do so, we need an ADSP or an ATM data service provider. And this is the glue for the other two layers. It's the key enabler for the benefits of the ATS and the physical layer. However, the common data layer also has socialization benefits of its own, because if you go from the current 65 FDPs, approximately, to a reduced number of ADSPs, then the service would be much cheaper. However, the question is, how many ADSPs we will have in Europe, and how are we going to trade them? Well, we have the IT giants, such as Google or Amazon, that can help us to bring a much cheaper and possibly better quality of service. This is something that we are still having to look into. The physical layer, what it does is that it provides all the data from the auxiliary services, so the CNS, the AAS, and the MED. And then the common data layer can integrate it into a single point of truth. In the physical layer, and in the current architecture, the auxiliary services are no longer dependent from the ACCs. So this makes the service become wider and scalable, and resilient at a network scale. Since the 2000s, study after study, we have seen that there are too many CNS assets, and switching from a national or small regional deployment to a wider regional and pan-European deployment that is done by specialized organizations such as SESAR or AARON will bring much benefit in terms of a coordinated deployment and an improved cost efficiency and service quality. Bringing all these benefits is not a technical challenge. Other industries such as banking or telecommunications have already proven it can be done. However, getting technology right requires an organizational restructure. And these changes do not happen overnight. They need to go through various stages until you get to your preferred one. Some ideas of the models that may appear are in this slide. So first, we might look at the alliance model, which is a group of NSPs that operate together to create a single entity or a joint venture that provides the common data layer and the physical layer services. In this model, it's collaboration that drives efficiency, and it's a really good model to try regulation on. Then there are other two models where you can have some competition. There are two options to this. You can make the common data layer competitive, or you can regulate the common data layer and incentivize competition on the other two layers. If you go for the first option, so you make the common data layer competitive, you have to ensure that you have at least one ADSP that everyone can subscribe to. And then you will have created a contestable market. And this has two things associated to it. First of all, if you have more than one ADSP, they need to be interoperable. And second, the physical layer, at least initially, will be operated by the NSP, which will be in charge of its assets. If, on the other hand, you decide to regulate the common data layer, then you will probably deliver an efficient service. And you can use the certainty that this creates to incentivize competition in the ATS and in the physical layer. This model is the model that best supports having one pan-European NDSP, and you might also start seeing a consolidation of the auxiliary service at regional and pan-European level. So, what we are doing in RoMiAD is looking at the different options that exist for each layer. We need to see how we can ensure that the benefits balance out the cost of the transformation. For that, we need to investigate how to best incentivize the transition. Of course, competition is an option, but this requires a genuine contestable market. And the problem of contestable markets might be having an excess of infrastructure. The solution might be to have competition on the market, which is an idea which was already proposed by COCTE study, with its capacity broker on the ATS layer. If you don't manage to create a genuine contestable market, you will have a monopoly market, and therefore you're forced into regulation, which is a financial makeup for the potential types of service providers to create the correct environment. Currently, the CapEx approach is limited for the future architecture, so it may be worth it trying a TOTEX approach. However, if we have NSPs that collaborate together to create economies of scale and value for money, then regulation can be lightened. This will suit the collaborative approach that the AAS is trying to promote. Thank you very much for listening in. If you have any questions, please let me know, write me an email, or contact me